Hey all, it's been about a year and a half since my last update on WireSlicerPy. Since then, I've added a graphical user interface for users to work with the program instead of having to do everything through a Python file. And I've also completed a lot of the whole management that I talked about in previous videos on this topic for both wings and for imported STLs. So what I'm going to do is I'll walk through a project that I pre-made for a 40mm EDF, and then I'll go through all the different windows and some of the features of the program and the user interface. So for the example project for WireSlicerPy, I'm going to be going through this model here. So this is a 40mm EDF with a main wing and two tail surfaces, and then the body is divided into a front and back fuselage. And this was done so that the reference plane for the slicing can be the opening for the inlets. So the rear section is sliced from this front surface going backwards, and then the front is sliced from this section going forwards. And that's so that all of the final geometry as cut from the phone has a solid reference point to the opening inlets, and then the front nose might be a little short or the rear tail might be a little short depending on how the division of your foam thickness goes into the length of the model, which ideally the length of the sections would match a integer division of the number of foam thicknesses you have, but most of the time it probably won't unless you plan that into the design from the start. So let's get started going through the program. So starting with this window, this is the home page whenever you launch the application. I haven't got changelog to work yet for this news window. I used to pull it directly from my GitHub commit history, but it turns out that only works if you have an active checkout of the GitHub repo. So I need to figure out how to import my change history here. But then over here we have recent projects. So pretty much any project that you save or load will show up in the recent projects tab, and you can double click to quick open them. So now that my project for my 40mm EDF is open, I can go to the CNC wire cutter page, and here we have all the settings for my CNC wire cutter. So I can add additional ones over here on the side, but for right now I just have my short configuration. So this is a photo of the way that my CNC wire cutter is set up. And one of the things I do with it is I adjust the length of the wire cutter. So I'll move the gantries further apart or closer together depending on what I'm cutting. So for a lot of fuselage pieces, I put them pretty close together, and I just call that the short configuration. And these are all the settings for it, along with dynamic tensioning that I added in the last episode on my wire cutter, and then some of the startup G code that I use for my wire cutter with Gerbil. So then I'm going to go on to the wing page. The wing page is where you define all of the wings that you want to cut out using like .dat files from the airfoil database. So you'll see I have two wings here, the main wing, which is a left and right, and then the tail, which is a symmetric airfoil that I'm just going to cut two out of. So as we go through, you'll see that there's a section XY and a section UZ. So this is typically the root and the tip of the wing. You have the chord, the kerf, and then the airfoil selection box for both the root and the tip. The name of the wing, which lets you know which one you have selected, the span, washout, sweep, and you can change all of these real time. You get different settings. These settings are for how the wire cutter sets up the cut, so the start height, start depth, and the release height of the cut. And these are similar to the settings you'd use in like Jetty Cut for having the wire enter and leave the foam workpiece. And then additional options down here, and then the selection of which wire cutter you want to use to create the G code for this cut. Because you could have, like on the CNC page, everything using short, but then you might have a long configuration that the main wing uses if it's too long to cut with short. And then down here in the advanced tab, we have this is where you add various holes for spars or for cavities. So right now I only have three hole setups, rectangular, circular, and cavity. And I can show an example of those working. So if I wanted a cavity, so this just hollows out a section inside of the wing based off of where the cord starts, where you want the cord to end, the wall thickness of the hollowed section. So like this isn't a very thick airfoil, so probably like 3 millimeters. And then the number of points that you want to use. And we'll add that, and then you can see that it added a hollow cavity section here that'll be cut out. I plan on adding a few more different hole types, but right now these are the only 3 I've really been using. So from here we'll go on to the CAD import section, which is where a lot of the more interesting stuff is. So this is for importing STLs and then the various options you have for slicing those into a cut pattern. So you have the settings for the workpiece, which is the foam that you're going to be cutting out of, and then the settings that define how it gets sliced down. So the number of subdivisions per slice, the gap between those sections, like on the foam sheet, so the gap between the various cut pieces, the number of points for each section, the kerf, the max kerf, because with these STL sections, it uses a dynamic kerf, so it scales based off of the speed of each gantry. The wall thickness, which is used for if it's adding holes. If the program is adding holes itself, it'll use wall thickness to insert holes into the piece. If you leave this as 0, then the program will try to import any holes that are in the STL already. And I can show an example of that because the 40mm EDF for this project has holes. So hollow settings, again, these are used if you do not plan on using the holes from the STL. So whether you want the leading section of the STL to be open, that is not a completely solid piece. If you want the tail to be open, and then you can also define a list of what sections have holes embedded into them. So this would be if you like want the first 3 sections to be completely solid, and then 3 hollow sections, and then the rest to be completely solid. So you could do 3, 4, 5, and then sections 3, 4, and 5 in the slice would have holes embedded into them. And then there's options for how the STL is. It pretty much controls how STLs are imported into the program. That is which axis of the STL is being sliced. So the primary axis is the longest axis. So in the case of a fuselage, think nose to tail. Nose to tail, there's a bunch of planes that are slicing out the fuselage. Secondary axis would be the second longest axis. So say if it's like a wide-bodied fuselage, it would be from wingtip to wingtip without the wings on there, obviously. And then the tertiary axis is the last one. And then you also have an option to flip the axis. So generally, it'll go from, in the case of primary axis, say the nose is at the origin and the tail is at positive X, it would go from origin to positive X. Or if you want to go from tail to nose, you could select flip axis, and then it would slice it in the reverse order. And then selecting the CNC machine. And then there's a few options here for, say that you want to play around with the settings a lot, you can do preview selected, and it won't go all the way through generating all the G code and all the section alignment. It'll just get it to the cross sections and subdivisions if you have subdivisions selected, and then display all of them here. Slice selected will just slice the setup that you have selected here, and then slice all will slice everything that you have in this project. And I forgot to mention it, but it's also on the wing page here. Slice selected in this case would just do main, and then slice all would slice every wing that you have set up in this project. So we can go ahead and do slice selected here to preview them. I will say that this takes a little bit, so I'll probably cut the video here and then come back when they're displayed. So Here we have the previewed selection. The slice settings I have selected generated 19 sections for this piece of the fuselage, and we can scroll through them and see the forward and aft sections for every cross-section pair. The orange being the forward section and the blue being the rearward section. So if you like the way that each of these sections look, you can go ahead and click Slice Selected, and then it'll generate the G-code based off the CNC wire cutter you have selected. Can also show an example with subdivisions. So I'll go ahead and preview selected and then cut the video to when it's finished. So now we have all the cross sections generated with 3 subdivisions per cross section pair. And you can see that we went from 19 sections up to 57 because every single one is divided into 3. So you can see the program properly handles the holes that are embedded in the STL, and then also subdividing those holes down into individual cross sections that can then be cut. So if you're happy with this, then you could go ahead and hit Slice Selected and generate the G-code to cut out. Unfortunately, there is still sort of a bug here. I can't figure out what's causing this, but occasionally the origin for the graphs will just be offset. That is where they're placed on the user interface. So you get ones that are offset like this. And then another bug I'm still trying to fix is when points are aligned on cross-section pairs or cross-sections that look sort of like this, where there's 2 points fairly close together that are closest to the origin, that is 180 degrees, pretty much whichever points are furthest to the left. It can have trouble selecting which point to use for both cross sections, and will sometimes use the top one for one cross section and the bottom for the other, which causes poor G-code generation. So sections like this too, and these ones. So I'm still trying to resolve that. If you don't have any cross sections that look like this, there shouldn't be much of an issue currently. But with anything that has multiple internal cavities, you'll probably end up with something similar to this depending on how many subdivisions you're using. So that's one thing to note. And then the last page is the edit database page, and this is really just defining folder paths to where your assets are located. So both STLs and your .dat files for airfoils. So on the left, we have the ones for the entire program. So these are shared across all projects. You can see there, for mine, it's just local routing to assets, airfoils, assets, STLs. And you can see those are in the file directory here. And then on the right side, you have the ones that are specific to just this project, the 40mm EDF. I don't have any project specific airfoils, but I do have the STLs, and these are in projects, 40mm EDF, and we can go to that folder, and you can see I have 3 STLs here, the rear and the front fuselage, and these are the ones that I was cutting in CAD imports. So rear has rear fuselage and front has front fuselage. Pretty straightforward. And then the project file that the wire slicer opened up is also located here. And then you can see the results of a slicing I did. So on the rear one, you can see that 5 G codes were generated, one for each, one for pretty much every workpiece required to get all of the cuts. So you can see these set up here. So this would be workpiece 1, 2, 3, 4, and then 5. And this is with 3 subdivisions. So you can, and then you can also look at the final cut paths that are shown here as well. So this is how the cut paths were set up. And yeah, you can see there's some issues with the point alignment, like I was saying. Most likely on one cross section it chose the top section of the curve, and then on the other it chose the bottom. So when it tried to align them, the starting point for one was very offset compared to the other. Same here. So I still need to resolve that before doing cuts like this. Otherwise, the actual G code interpolation ends up being very off. You don't end up getting the slices that you expect from the two cross sections. So hopefully I get that resolved pretty soon, and then there shouldn't be too many more issues past that. So yeah, that's pretty much what I have right now. In terms of what I still have left to do, there's a lot of bugs that I need to pretty much still find and fix the ones I already know of. I'm sure that there's a lot of bugs in here that I just haven't encountered yet because I'm familiar with how I wrote the program, so I'm using it the way I expect. But if another user uses it, they'll probably find stuff I didn't expect that's not working quite properly. Or, you know, various geometries, STLs I haven't, different forms of STLs I just haven't tested yet. And then in terms of wings, I'd like to add a few more hole styles like triangles for control surfaces for cutting out the hinges, and then potentially auto-generated slotted flaps for the back, and then forward slots for the leading edge. That would be pretty cool. But yeah, that's pretty much where it's at. I have tested this on Linux and obviously Windows. I do have an exe for Windows that I've been generating. It's in the GitHub location. Having the exe is actually how I found out that this home thing did not work, because I was running it through PyCharm from an area that had the GitHub repo, and then I made the exe and then moved it to a Surface Book I have, and then it just kept crashing because, oh hey, it can't grab the changelog. That's awkward. So still need to test it on Mac. I don't own a Mac, and I don't know anyone that has a Mac. So hopefully it works on Mac. On Linux it works, so at least there's two platforms down. Thanks for watching, everyone. I hope this program is useful to some of y'all.